Hey ladies and gentlemen, we're ready for our next math lesson, lesson 1.3 on equivalent fractions. You'll see the I can statement at the top. I can relate equivalent fractions to the multiplication table. I'd like you to pause this video and jot that right down in your math notebook. Remember, this should be a brand new page. At the top you should put lesson 1.3 equivalent fractions, and here you need to write the I can statement below that. So go ahead and do that now. Now, one thing I want to remind you of is that anything that's confusing to you, you're like, ooh, I may need to write that down so I remember. Please do so. Remember, you're in charge of your learning, so if you know, hey, I need a few more notes, go ahead and do that. I had a student tell me today, hey, this wasn't too bad. I just grabbed my math notebook and when I was doing my seat work and I just looked back. That's exactly why you have your math notebook, so it can be there as a tool for you to use throughout the year. All right, so let's get started. This, ladies and gentlemen, is a multiplication table. I am certainly hoping you've seen one of these before in your lifetime. We are going to use that multiplication table to help us create equivalent fractions for the fraction 3/5. So what I want you to imagine here is the numerator row is the row that has 3 in it. The denominator row is the row that has 5 in it. Okay? And at the top we've got our multiplier. So we've got 1 through 10 up here. So here we have the first 10 multiples of 3. Here we have the first 10 multiples of 5. So let's look at down here at the bottom here. We've got some different equivalent fractions here. So we had 3/5. 3/5 became 6/10. Well, how did that happen? Well, we multiplied both the numerator and the denominator by 2 to give us 6/10. And that's a really important point. I'm going to just kind of segue here. You need to understand that if you are going to create equivalent fractions, you have to. I'm telling you right now, don't come me. You have to multiply the numerator and denominator by the exact same number, or it is not going to work. Okay? Just take my word for it. I've been around for a while. Not quite as long as dirt, but I've been around for a while. All right? So, right down here is our multiplier at the bottom. You can see times 2. I just pointed at the screen. You can't see me pointing at the screen. But look down here now. So you can see our multiplier is times 2. So let's look at 9/15. How do we get 9/15 out of this? We'll use the multiplier of 3. 3 times 3 is 9, and 5 times 3 is 15. That's how we get 9/15. So how about 12/20? Well, we use 4 as our multiplier. And you will see that pattern 5, 6, 7, 8, 9, 10. You can see all of these are equivalent to 3/5. They all mean the same thing. Now, when you're looking at 3/5, I also want you to recognize that that fraction is in simplest form. The only factor that 3 and 5 share in common is 1. There's no other number that goes into both of those numbers. All right, so let's take a look at this again. So now we're going to look at this again, but we're going to look at it with 4 is the numerator row and 7 is the denominator row. Okay, and up here we still have our multipliers at the top here. And down here, 4/7 became 8/14. Well, how did that happen? Well, we multiplied 4 times 2, and we multiplied 7 times 2. Remember, numerator and denominator have to be multiplied by the same number. That gives us 8/14. If we multiply by 3, 4, 5, 6, 7, 8, 9, 10, we could keep going. Our multiplication table doesn't go that far, but we could keep going. But you get the idea. As long as we multiply the numerator and denominator using the multiplication chart by the same number, we're going to get equivalent fractions every time. Okay? If it was 8 and 9 as our rows, that would work too. Okay? So we'd have 8/9, 16/18, so you can see how that would work. All right? So hopefully that clears some things up. That's a great way to get equivalent fractions. Now, I want you to think about this. All right? How can you change 3/5 to 18/30? Think about it. What would my multiplier have to be to make that happen? Well, I would multiply the numerator and denominator by 6. Make sense? Look up here. 6 times 3 is 18. 6 times 5 is 30. How can you simplify 18/30? Well, you can do that by going the opposite of what we just did here. This time we multiply the numerator and denominator by 6. How about this time we divide the numerator and denominator by 6? Works both ways. If you're going to do it to numerator, you have to do it to the denominator, whether you're reducing or if you're making that fraction with a multiplier. Okay? So, next one. How can you change 3/5 to 27/45? What would your multiplier have to be this time? Hopefully you came up with 9. You multiply the numerator and denominator by 9. And last one, how would I make 27/45 into 3/5? I would divide the numerator and denominator by 9. That would give me back to my 3/5. All right? So here is what I want you to think about next, because we're going to get ready to get into the practice problems, but there's just a couple things I want you to conceptually think about as we go through this. When you divide the numerator and denominator by the same number to make them smaller, you are simplifying the fraction by making larger unit fractions. So what does that mean? Okay, well, what that means is if I look at 3/5 here, we'll just use the ones we've got. In 18/30, if I've got 1/5, that unit is bigger remember, because unit fraction has to have that numerator of 1. If I've got 1/5 and 1/30 of the same thing, 1/5 is bigger. It's making a larger unit fraction. It's worth more. Okay, kind of like the pizza example we talked about in class today. When you multiply the numerator and denominator by the same number, you are unsimplifying the fraction by making smaller unit fractions. So let's talk about that again. We'll go the other way. If I've got 1/5 and I turn that into 30ths, I'm unsimplifying that fraction, because now I'm not only do I have a fraction that's not in simplest form when I've got 18/30ths, but I'm also making that unit fraction smaller. I'm now taking that great big pizza and I'm cutting it into little bitty slices, about 30 of them. You can imagine what a 30th of a pizza would be like, not very much. But a 1/5 of a pizza, that would be a good sized slice. All right, so here are your practice problems. Here are the directions for you. Copy the problems below into your math notebook. Write the multiplier or divisor for each pair of equivalent fractions. So in problem number 1, it says 4/7 equals 28/49. What's the multiplier that we use to do that? Problem number 2, 15/50 equals 3/10. What's the divisor that we use to make that happen? And if you have any questions about this, we can cover it in class tomorrow. Hopefully we're doing well, and we'll see you soon.